Hello everyone, welcome back to the channel. So today we'll be doing the chapter Health Information and Basic Medical Statistics. So we first see the definition of health information, and then we see information versus data versus intelligence, and then we see the WHO requirements for a health information system, which I'm gonna abbreviate as HIS. And then we see the components of HIS and the uses of health information. And then we see the various sources of health information. It can be from a census, it can be from a vital event registration, it can be from a sample registration system, and the notification of diseases, hospital records, disease registers, which is not the same as notification, then record linkage, which would refer to inpatient records mainly, and epidemiological surveillance activities, and then other health service records, wherein this is where we deal with OPD records and stuff, and then environmental health data, health manpower statistics, population surveys and survey methods, in which you have four methods: the health interview, health examination, health records, and mailed questionnaire methods. The National Sample Survey Organization deals with health interviews. Then we have other routine statistics like demographic, economic, and social security schemes, and other non quantifiable information like health legislation and public attitudes, etc. We now move on to statistics. So, what are the elementary statistical methods we usually use? Before that, we see the various methods to present data on hand. So, first we have tabulation, in which we have simple tables and frequency distribution tables. Then we have charts and diagrams, in which there are bar charts or bar graphs, like simple, multiple, and component bar graphs, a histogram, and then the frequency polygon, then a line diagram, pie charts, and pictograms. Then we see the main statistical averages we frequently use and which we have also frequently heard since, I guess, high school. So there's the arithmetic mean, the median, and the mode. Now moving on to measures of dispersion, we have range, mean deviation, and standard deviation. So mean deviation is basically sum of the deviation of each value from the mean by the sample size, that is n. In standard deviation, you instead square each deviation and then you take the square root of the whole thing. So what is inside the square root is known as a variance. And if n is less than equal to 30, the denominator is n minus 1. We then see what's normal distribution. We discuss the normal curve and a standard normal curve. A standard normal curve is one which is perfectly symmetrical, bell-shaped, and it's over infinite number of observations. Its total area is 1, and the mean, mode, median are all 0. And then we discuss what are confidence limits in a normal curve. So we have the mean here, which I have marked by x bar. This is not to scale, guys. And then we see x plus or minus 1 sigma, the interval. Sigma is nothing but standard deviation. Then plus or minus 2 sigma and 3 sigma. So within one standard deviation, you will get 68% of the values. Within plus or minus 2 standard deviations, you get 95% of the values, which we would express it as 95% confidence limit. And then for this, we take the p-value as 0.05, which is nothing but 100% minus 95%, which is 5%. That's the probability of obtaining an extremely unlikely value outside the confidence interval, assuming a null hypothesis is true. We'll discuss about the null hypothesis later on. So similarly, for the p-value for 68% confidence limit would be 0.32 and so on. We also see what is relative deviate or standard normal deviate. That's basically the deviation by the standard mean, which we express as z of x. We then see what is sampling, what's a sampling frame, and what are the various sampling methods like simple random sampling, systemic random sampling, and stratified random sampling. These are only three ones that are given in PARC, but there are more which I will discuss now. So we can categorize sampling methods into random or non-random or probability and non-random or non-probability sampling methods. So under random methods, we have simple random sampling in which you have the lottery method, which is basically picking up chits, and random is a random allotment of the samples, which is can be done on a website called random.org. And then systematic sampling is wherein you prepare a serial list of your samples, get the sampling interval, which is basically the population size by the sample size. So you randomly choose the first subject. The second subject serial number is your first subject serial number plus the sampling interval. And you then repeat the same until you exhaust your sample size. Stratified sampling is when you divide the population into various strata based on few criteria like economic status, etc. And then from each strata, you can sample. So one method is disproportionate. You will actually understand this better when I discuss proportionate. So there are three strata, let's assume, with 20, 40, 40 samples in each. So proportionately, we have sampled 5, 10, and 10 into so total 25 subjects out of a population of 100. The samples selected are proportionate to each strata. They're kind of representative. That doesn't happen in disproportionate sampling. Now moving on to cluster or area sampling, you basically divide the geographical area into clusters, and then the clusters for this study are selected by simple random or systematic sampling. Now in multi-stage sampling, the first step you would do cluster sampling, and then you would subject each cluster to another round of simple or systematic sampling. Now moving on to the non-random sampling methods, you have purposive sampling, quota sampling, convenience sampling, and snowball or referral sampling. You would have a different mean for a population level and a different mean at a sample level. So for a population, you would refer to the mean as mu in this textbook and standard deviation as sigma. And for a sample that you're sampling, you would represent the mean as x bar and standard deviation as s, simple s. We then see various sampling and non-sampling errors, and then we discuss the tests of significance. Firstly, the standard error of the mean, which is your sample standard deviation by root of the sample size. So to see the difference between the standard mean and population mean, we now discuss the p-value and the normal deviate and how they're all related to the confidence limit. So if mu is outside 95% of your confidence limit, your normal deviate would be more than 2 and your p-value would be less than 0.05, which would mean that it's significant difference at 5% level. If mu is just within the confidence limit, your ND is equal to 2 and p is equal to 0.05, which is just significant at 5% level. And similarly, it goes for when mu is well within your confidence limit. ND would be less than 2 and p is more than 0.05, which is not significant. Next, we have the standard error of proportion, which is root pq by n, wherein p is the proportion of one of your sample. For example, the proportion of males in a population, and q is 100 minus p. You're representing p in percent. So we then see the relative deviate, which is basically the sample proportion minus the population proportion of your whatever you selected as a sample by standard error of proportion that you have calculated. We then see the standard error of difference between two means, which is useful in comparing the means between two groups like cases versus controls. So it's root of sigma 1 square by n1 plus sigma 2 square by n2. Similarly, we also have the standard error of difference between two proportions, which would basically be root p1 q1 by n1 plus p2 q2 by n2. We then have the chi-square test to see the significance of difference between two proportions, which is very important especially in terms of practical exams. So firstly, we see the null hypothesis. We see what's an observed value and an expected value. And then we check chi-square of the observed values, which is sigma of observed minus expected value whole square by expected value, that's E. We then see the degree of freedom for the given set of values, which is columns minus 1 into rows minus 1. You have to represent it in a tabular form here, by the way. And we see the probability table wherein we find appropriate chi-square value for the given degree of freedom. And then we compare the two chi-squares. If chi-square observed is less than chi-square from the table, the null hypothesis is true, and vice versa. We then see what is correlation, which involves two variables x and y. So the correlation coefficient r is sigma of x minus x bar into y minus y bar by root of sigma of x minus x bar into sigma of y minus y bar. Similarly, we have something called coefficient of regression, in which we can express one variable using the other. So here y is equal to y bar plus b into x minus x bar, wherein b is the coefficient of regression of y upon x, which is sigma of x minus x bar into y minus y bar by sigma of x minus x bar whole square. So that's it for today, guys. Thank you for watching. Hope this is helpful. Do leave any feedback in the comments, and like, share, and subscribe. And thank you all once again. Stay tuned for more.